Okay, good morning, everyone. Now we come to our final class lecture. And I know this class has been a lot of work, and I'm very pleased with all your efforts and work, and the whole class has put into this workshop so far. Everyone has just been amazing. For 6 months with all the homework and all the assignments we've been given, not one team has ever failed to complete an assignment. I'm just truly amazed, and you all get an A in the class. And we still have a little more work to do. So let's go through this agenda today. So the intent of this class is to really have a deeper understanding of life's principles. So we'll have each individual team go through the ones that they've been assigned. So when we're also going to learn how to use life's principles to evaluate the solutions that you come up with. We're going to learn how to communicate biology to engineers and use biomimicry language in your work. We'll do an eyesight sharing. We're going to do an update on the in-person session and the homework that's due, and then have time for questions and comments. This time I've included 4 case studies, as this is my last chance to do so, and these were just really cool examples. I couldn't choose between them. So let's get started. So soon, most of us, or some of us, will meet up in person at the Great Sand Dunes National Park and Preserve. I hope you all will bring your newfound ability to observe nature through your eyesight to this workshop event, as there are many wonderful natural organisms to observe in this really special place. I've read some of your eyesight observations, which were submitted as part of the summary reports, and it was almost like being there with you. I think the ones I read were just amazing. And I'll ask right now if anyone has an eyesight they'd like to share. You can raise your hand, and we'll also have time to talk about our eyesights at the in-person session. So Mila, has anyone volunteered?
I don't see any volunteers at this time.
All righty. Well, let's go into some of the examples. So I wanted to tell you about this biomask. So many viruses, including influenza viruses, are known to bind to a salic acid residue on the surface of human cell membranes, as shown in this first figure. Salic acids are found widely distributed in animal tissues, providing an important function to keep water at the surface of the cells. The salic acid-rich regions help create a negative charge on the cell's surface, which attracts water. Viruses are also attracted to this negative charge. The center figure here shows that viruses are 10 to 100 times smaller than bacteria and can easily pass through conventional face mask filters, which trap particles based solely on their size. The green grid represents the pore or hole size of conventional face masks. Villigent has developed a medical device, face mask, that traps viruses and bacteria by mimicking the salic acid receptor sites on human cells to which they normally attach. Villigent uses what they call intelligent filtration by creating a negative charge in their medical face mask using a safe binding agent to attract and prevent bacteria and viruses from entering the body. By creating a negative charge to attract to the smaller viruses, the pore size in the mask does not have to be reduced, which can block larger molecules and make breathing difficult for the user. Villigent's bio-friendly face mask traps and kills 99.9% of viruses and bacteria without antibiotics. Tiny amounts of copper and zinc ions disrupt the viral envelope or bacterial cell walls and inhibit normal metabolism. And so this technology is also being used to make materials that would cover hand-holding devices or doorknobs, other places where viruses and bacteria dwell in hospitals. So good idea, good mimicking idea. Cuttlefish are well known for their brilliant color changes, and they're even known as the chameleons of the sea. Sometimes they produce a zebra stripe pattern that even appears to move across their body. They have several ways of doing this, and one of them has inspired scientists to design a new type of TV screen with very low power requirements. It's under 1% of the power needed for normal screens. And we know that as people have purchased larger and larger screens, one of the problems is that they are big energy users. So a team of researchers led by Edwin Thomas at the MIT School of Engineering noticed that cuttlefish change their appearance in a few seconds by secreting special chemicals to alter the spaces between their membranes. This low-energy technique seen in cuttlefish has been mimicked by the researchers to develop a low-power display. These researchers have developed a prototype screen that is several inches across but only 1 micron thick. This narrow space is crammed with polystyrene layers that mimic the layers of a cuttlefish. When no current is applied to the screen remains clear, but as the voltage increases, the polytube membrane expands while reflecting incident light. Since the poly layers expand according to the voltage applied, the display reflects different colors at different voltages. The screen doesn't emit light, which is why it needs very low power. But this means it needs an external light source shining on it, and it needs to be viewed from right in front because the image color changes with the angle. And MIT isn't the only institution working on reflective screens. Microsoft, Sun Chemical Corporation, and the University of Cincinnati and Cornell University all have active reflective screen research units, all for a variety of different purposes. Electronic ink applications, pressure sensors, and advertising billboards are only a few of the potential applications. And what's being mimicked here is the process that the cuttlefish uses. So here's some garments that use a technique from nature. So mimicking fur is a much better idea than wearing fur. So Nick Wax, an analogy, is a fabric system for weatherproofing clothes that mimic fur. It has been developed by Nick Wax, a supplier of waterproof fabrics. Nick Wax Company is owned by Nick Brown, an outdoor enthusiast whose first product was a natural waterproofing wax for outdoor boots. He named it Nick's Wax and started his company, Nick Wax, in the 1980s. Some of you may be familiar with it. I use Nick Wax to waterproof my boots. The fabric system is made up of 2 layers. The inner layer is called a pump layer. It is designed to push the moisture away by means of capillary action. The outer layer is called the shell layer. It slows down the incoming wind and rain. When both the layers combine, the pump layer is able to push water away from the wearer at a rate which keeps them dry. Just like fur, Nick Wax analogy causes water to flow away from the body, with water moving out faster than it arrives. Nick Wax owes its strength to 2 features. First, the fabric structure of the pump layer, which mimics fur, and second, a durable water-repellent treatment on both layers. Both layers rely on a durable water-repellent treatment. This treatment, in combination with the biomimetic fabric structure of the pump layer, creates a capillary depression effect that allows water to be driven away from the wearer. In common with other waterproof garment technologies, this water-repellent treatment must be maintained in order to be effective. Nick Wax analogy is better than conventional water fabrics in 2 ways. First of all, since both layers are porous and permeable, Nick Wax fabric is more breathable than waterproofing relying on a single non-porous layer. The highly breathability of the system makes it more suitable than conventional hard shell waterproofs for general use. And secondly, unlike most waterproof breathable fabric, Nick Wax fabric can pass out liquid water as well as vapor. So an adult working hard can produce up to 1 liter of sweat per hour and no breathable waterproofing can transfer that amount of water as moisture vapor even when the outside air is dry. The main user of this Nikwax fabric is Nikwak's sister company, Paramo. Paramo produces waterproof outdoor wear. They are also small specialist suppliers which produce garments from other fabric as well. So the Paramo's clothes have a loyal consumers among the UK mountaineers, but they're not mass-produced in international products yet. And so what's being mimicked here is the form of the fur. And finally, this is a medical adhesive technique. So when a bone fractures into many pieces, doctors can reattach large fragments with metal screws and pins. But when a complex fracture involves many tiny fragments, they are often too small to be reconnected. So physicians have long sought a medical device for the job, and Russell Stewart from the University of Utah has recently found one, inspired by the glue secreted by the sandcastle worm. So sandcastle worms live in an intertidal zone among most temperate coasts where they build large colonies by gluing together sand grains, and you can see that in the first photo. Tentacles gather food and sand, as seen in the second photo. The glue begins as a water-based soup of several charged proteins and ions of calcium and magnesium. It's made in a gland that is mildly acidic, which maintains the glue as a liquid. When it's ejected into seawater, which is alkaline, the rise in pH causes the glue to set. It solidifies into a form within 30 seconds and becomes a flexible, leathery, waterproof substance in several hours. To develop a water-based synthetic medical adhesive, Dr. Stewart mimicked the sandworm's glue recipe by using 2 synthetic polymers in place of natural proteins. The adhesive sets in response to pH changes and to temperature changes. So it's a liquid at room temperature and a solid at body temperature. It adheres to bone fragments and it bonds them together with twice the strength of the worm's glue. The glue is in early stages of development, but preliminary tests suggest it's both non-toxic and biodegradable. Sandcastle worm glue is an inspiring, biocompatible, biodegradable adhesive, and it reduces metal hardware in the body while maintaining proper alignment. So what's being mimicked here is the process that the sandcastle worm uses. So I hope you enjoyed all those examples, and there's many more out there. So let's talk a little bit about life's principles. So we introduced the topic at the beginning of the webinar, and we went into more detail about it last month. But what are life's principles? They're powerful strategies for survival. They're important tools for strategic design. And they're what biomimics use to both drive and evaluate the sustainability and appropriateness of our designs. So in each of your challenges, you're looking for strategies that nature uses to conduct the specific function that your team has identified. What life's principles are is that they are the abstracted strategies that all organisms, or 99.9% of all organisms, use. So they're a general group of the strategies that nature uses. And what you're discovering in your abstraction is the ones that some organisms use in response to the specific challenge that you've identified. So they are the deep design principles common to all organisms, and each team was tasked with one of life's principles to explain to the class. So let's hear what you found out. I'm going to go through the teams as they're listed here on this little chart. So first we'll hear from Team H2O, then Team Adapt, then Team Organize, and Team Communicate. And so Mila will turn on your microphone. If you are the person for the team who's going to present, then raise your hand and Mila will turn on your microphone. So we'll start out with Team H2O, and they had be resource efficient.
Okay, so Team H2O, I think that this is going to be Mary Blanchard who's going to present for us, I believe. Is that? Well, I will unmute Mary and see what she has to say.
And just say next when you want me to go to the next slide.
Okay. Okay, can you hear us, Mary? Or can we hear you?
I hope so.
Okay, is this right? Are you going to present for us, or?
I guess I am now.
Okay. Well, yeah, I think we didn't do a very good job at deciding who was going to present for us, but
no, that's fine.
Are you good? Okay.
I'm good. Yeah.
Okay. All right.
All right. Well, we kind of selected a few different of the items to focus in on, and we tried to find human examples for many of our categories, but we weren't as successful as in nature. So for the first slide, to skillfully and conservatively take advantage of local resources, our focus has been on water, so we've been really focusing in on desert species. So our nature example, we found a number of desert-dwelling species that emulated this lice principle, in their shallow root systems and their tough skins that allow for photosynthesis to happen, but don't allow for water to escape at an appreciable rate from their tissue. The example of the barrel cactus, which it can contract and expand, depending on how much water it's containing. So those were some of the examples we found in nature of this lice principle. And then a recent, well, it's not so recent, but it's a growing phenomenon, is the farmers market and community gardens movement, where folks are, recognizing that they're going to get a lot better tasting food that's not treated with pesticides, and the amount of fertilizer is significantly reduced, by growing in smaller plots in these community garden type settings. And so, especially in Durango, we're seeing a lot of growth in this area. So that's our example there. If you want to pop on to the next slide. Multifunctional design. Again, we focused in on dry weather species. The Hottentot bread plant, has a multifunctional design. It's got the cork-light root system that both cools plant and deters predators. Has a multifunctional use, and also the agave. It can collect water with its vegetation, but also it's got a shallow root system, so it figures out several different ways to collect water and also keep the water that it has with its tough skin to minimize evaporation. You can go on to the next slide. Using low energy processes, this has really been one of our big focuses because we're looking at ways to collect water from a variety of places. So one example in nature is just the capillary action. The redwood trees can pump water hundreds of feet into the air. This celery stalk illustrates that process in action. And then the second example is the replication of using microfibers to collect water and distribute it through an irrigation system. This is a new technology that I just discovered in putting this slide together. So it's pretty neat that folks are using this, and it also helps minimize the evaporation of the irrigation, that typically happens with most irrigation processes. Next slide. Recycling all materials. We had a couple of examples. I thought about you know, putting in some human examples, but we're a long way away from doing that process efficiently. But the spiders are able to you know, not only produce these beautiful webs, but also you know, when they get done, they can ingest the thread and recycle it back into new thread for new webs. And then also, you know, just a real simple example is nutrient cycling through tree litter that provides not only you know, nutrients for other vegetation, but also holds moisture into the soil for those other you know, vegetation to germinate. Okay, do we have one more, I think? Is that it?
No, there's
That's it?
one more. No. There's one more.
There we go. Yep. Fitting form to function. I mentioned earlier the barrel cactus. You know, it's got this kind of accordion type design that allows it to expand and contract as it's absorbing and utilizing its water that it's storing. It allows it to also cool the plant as well. So that's a pretty neat example. And then our human example is the respiratory system. You know, the lungs have been infolded to help save water, but it also provides for a you know, a high surface area for exchange of oxygen and CO2 across the lungs tissue.
Okay, well, great. I really enjoyed hearing about some of your examples. Were new ones for me, and it was good that you had so many from nature, because that's what we're trying to learn from. All right, good job. Okay, Team Adapt. Who's going to present for Team Adapt?
I'm just waiting to see a hand raised. Who is on Team Adapt? Marie, do you remember?
Kirk is on, and Laura Ferris, and Lynn, and Margot, and Sarah.
Okay, well, if I don't see a hand raised, I'm just going to randomly choose one of you guys.
And if no one feels like presenting, I can go through these. So.
Well, I don't see anyone raising their hand, but do you want me to choose someone, or how about maybe I'll call on Kirk and see what he has to say. Since I know Kirk, I can pick on you.
They failed everyone out again.
Yeah. Yeah, we can hear you.
Okay. Yeah, I don't know. We didn't talk about who was going to present. I think that, you know, so we've been kind of focusing on a variety of the climate change issues, especially with respect to the Front Range, but also looking far and wide for good examples. I think that, you know, we see a variety of strategies, like on the slide here, of how nature deals with drought. You know, where plants or animals can go into various kinds of inactivity, even dry out fully, yet are able to, you know, resurrect once moisture returns. And a couple other examples that aren't on here. One is that fungi networks kind of below ground can form a whole network that stores a lot of water that's available both to the fungi but also to the to other plants nearby. And the ice plant there at the bottom of the slide has these kind of surface bladders to store water that help it not only in drought conditions but also if the conditions are highly salty, helps them deal with the salt. And so you see some things where the water storage is both decentralized and redundant, so there's a lot of backup. As humans, we've kind of gone with the large reservoir kind of model, and of course the opportunities to do this are becoming more and more difficult to find. There's a lot of damage with these. So people in LA have proposed to put in cisterns to capture water from parking lots, from roofs, etc., and then use that for irrigation, etc., in a decentralized fashion. And this not only catches stormwater that wouldn't be used, and then it's able to use it later when you need it, but also it reduces kind of the peak stormwater flows, which is a big issue in a place like Los Angeles that's so heavily developed. And other plants and ecosystems have other variety. Is there another slide, Mila?
There's several other slides, yeah.
So there's the fungi networks. The other one that was really fascinating is the mangrove has a variety of strategies that it uses with respect to it kind of drops a seedling that has like a spear-like point, so if it lands on land or in the mud, it'll stand up and establish roots very quickly. But if it lands in salt water is more buoyant than fresh water. The whole seedling will float horizontally, and the seedling can actually perform photosynthesis while it's floating in the salt water, so it can stay alive. And then eventually, if it floats into fresh water, which is less buoyant, the seedling turns vertical, and as soon as it touches down against the bottom, it will again establish roots quickly, so it can regenerate. So it's really kind of covered all the bases, so to speak. And I think that this is something that, in humans, we probably need to create systems that are much more diversified and flexible to respond to various conditions. Like above there, the ponderosa pine is able to get water both from deep root systems, but also from shallow, so lighter rainfall conditions, and is able to get water as well. Again, working with fungus to help supply nutrients. So next slide. We saw in a variety of ecosystems have multiple strategies that they use. In the prairie, certain plants that do better in cooler conditions, some do better in warmer conditions. And like in the wetlands where you have a lot of change in water level, the plants will kind of establish informal soil seed banks that can last for a long drought. But again, once the water returns to the wetlands, those seed banks can respond quickly and establish virtually the whole ecosystem, simultaneously. And again, this other one, the nurse shrubs, this is a Mediterranean forest strategy where certain shrubs kind of protect tree seedlings by protecting them from the hot sun and from animals that would like to graze on them. And also the shrub is helping modify the soil properties so that the trees also find a favorable condition. And then also I think we saw a variety of other ecosystems that use kind of the multiplicity of topography, of exposure to sun, elevation, stream channel versus up on the hillside, and use this variety to again buffer up from varying conditions. So the communities on the hillsides are more protected from flood-like conditions, but the ones down in the stream channels are more able to find water in a drought kind of conditions. So this kind of variety that they establish helps them maintain through different conditions.
Okay. And
any other slides?
The 2 slides for people.
Okay, I'll
All right,
turn
thank
it
you.
over.
That was really interesting.
Well, there's 2 more slides that tell how humans use these strategies. So I can just go through them real quick. So what the team felt was that to maintain integrity, humans take vacations. We self-renew through that, and we eat well and sleep enough and laugh and play, and those things are things that help us renew. And to embody resilience, and the team felt like they would say the old expression, don't put all your eggs in one basket, is a wisdom that recognizing that having multiple sources of necessary resources provides some additional survival capacity, and that it might be the capacity to personally be competent in many realms and be better able to take care of ourselves in a wide variety of circumstances. So the team ADAPT has done a great job in looking at a lot of different examples, and we'll hear more about those in the workshop. So good job. So next team for integrating development with growth.
And which team is this? What's the name of the team?
This is team. Go back, see who's the next on the list is Team Organize.
Okay, so this is going to be Doug.
Okay.
Okay, can you hear us, Doug, or can we hear you?
Can you hear me?
Yep, we can.
Okay, well, we are integrating development with growth. Team Organize has been kind of looking at how do different organisms and organizations thrive in times of resource constrictions or chaotic events. But we went through our life's principles and we started looking at our eyesight observations, and we noted that both aspen groves and sumac stands kind of extend leaders out for new growth, and they do it kind of year by year. And if you look at the aspen stand on the left, you'll see last year's reaching out. There's that first little aspen tree a couple of feet tall, and then this year it sent out another leader sort of successfully testing that this area was a good area to advance. And similarly, the sumac has done the same sort of process. It kind of sends out leaders in all directions, but only those that seem to support new growth are the ones that they reinvest and continue to add new leaders to in the next year. So that's an example of build from the bottom up and kind of working, one iteration at a time. Can you go to the next slide? And this is our human example. Tom Shoes basically started, from an all-volunteer staff. He started with himself, and then, basically recruited people on Craigslist, and then those volunteers eventually became paid employees of Tom's. And Tom's is also combining modular and nested components by using college students kind of as a training ground and training in doing social good along with their business promotion. Can we go to the next slide? The next principle is combined modular and nested components, and we've had a good example with some observations of beehives, and beehives obviously have the nested or the modular cells, and then they are able to nest combs of these cells together to create the colony, and they expand as the resource base allows them to gather more nectar and grow the hive. They can expand and add these components, and also they can add more cells and actually decrease those cells if they want to, and use that material as both a food source and as a resource for building new comb material. Next slide. The next slide principle was to self-organize, and bee colonies kind of make a collective decision to divide the hive when conditions dictate, both the amount of available space for hive expansion and honey stores might become limited, and so they need additional space for growth, and if they're physically limited, they collectively determine to create a new queen who then sort of succeeds the former queen in that location, and the new or the old queen has to take half the hive with her as she goes out and searches for a new location. And they put the most potent and virile queen in the location where she's going to be most likely to survive, and that's in the existing hive, while the old queen, who is probably the least viable, goes out with the new colony. So she's the most at risk, but the least able to promote new growth and development until she creates a new queen in a new location. Next slide. And then this open space meeting is basically a way to self-organize. I'm not very familiar with this, but this was one of the ideas brought to our group on how these agendaless conferences and meetings can actually help to organize a workforce or a group of employees without necessarily being dictated by management. Next slide, please. And then another human example is Pixar, and they have a central common area that all employees must go through when they come and go to work and when they take breaks, and basically it promotes spontaneous conversation and allows kind of the creative exchange of ideas in a common area, and basically allows people from different components of the company to get together and share ideas without necessarily having an agenda or a reason to meet, but just an opportunity to connect. I think that's it.
Yeah, and those are some great examples. Your final example of Pixar brings to mind, for those of you who knew EPA in our old building, we had a centralized area like that in our old building, and we were able to exchange a lot of information between different groups in the agency. And our new building does not have that, and we recognize that as a real lack of coordination and spontaneous discussions with people because we no longer have an area where we can self-organize. So I think that's a really good example of how people can self-organize around ideas. Okay, our final team is Team Communicate for Be Locally Attuned and Responsive.
Okay, and that is Diana, but I am not sure. I don't. Your little phone. I think we've had this problem before, Diana, or maybe it was somebody else. But the computer doesn't. Oh, there you go.
Oh,
okay.
Thank you. So you can hear
there,
me?
Diana? Yep. Gotcha.
Oh, thanks. We understood this, a little differently. We just prepared one slide, so this is it.
No, you have several slides. You have 2 slides.
Oh, okay.
Yes.
Great.
Okay. Yes.
I'll be curious to see what the next one is.
All right.
So we were looking at being locally attuned and responsive. So that is to fit into and integrate with the surrounding environment using readily available materials and energy, cultivating cooperative relationships, leveraging cyclical processes, and using feedback loops. And so we looked for examples within nature, human examples, and then we also include some eyesight observations. And the first one is a human example, flexible, adaptable apartment buildings. And the company there, Sweeney and Company, are architects. And what they did was design some apartment buildings that would be locally attuned and responsive to community needs. And their design is called Flex Nature. And it doesn't directly mimic a particular organism in nature, but the apartments are designed to meet people's changing needs. So as maybe a single person, then a married couple, and then a couple with children, and then the children leave, and then it's back to a couple again. The apartments can be enlarged or contracted depending on the needs, and they minimize the materials, but they maximize flexibility. And so that seems to be responsive and locally attuned to the community's needs. And it also, we're looking at our Team Communicate is looking at building community, and one of the things that this does is also maintains and builds community by allowing the people in these apartment buildings to stay there as their lives may change. They can stay in that space and build relationships with their neighbors who are also able to stay in that space because their living space is flexible. In addition to meeting this life principle, it also seemed that it integrated development with growth by combining modular and nested components, which the last group just talked about. It's resource, material, and energy efficient, and it adapts to changing conditions. And it was inspired by the flexibility and resource efficiency of the paper wasp nest, which there's a picture of the beautiful design, and if you've looked at how a paper wasp nest is constructed, it starts out small and then as needed grows, and it's locally attuned and responsive to the needs of the paper wasp. So that was our first example, and then
Diana, excuse me, your second slide is almost identical to your first, but it has some additional information, so I'm just going to switch to this slide. There. Okay, continue.
Oh, okay. Okay. The second example is permaculture and perennial cropping. And this is something that Marie talked about in one of our previous, I think in the 4th webinar, talked about Wes Jackson's Land Institute in Kansas. And he's really been inspired by the resilience of prairie ecosystems. And he's written a book called Consulting the Genius of Place, where he talks a lot about the whole concept of perennial grain cropping and how if we mimic how a prairie ecosystem is put together, it would completely change the face of agriculture as we know it. And so so his research is looking at native prairie systems to learn from nature, and the perennial grain cropping systems do mimic the natural prairie ecosystem. They're resilient, diverse, drought tolerant. They've got the prairie plants, as the previous, I think Team Adapt talked about, some species will really thrive under wetter conditions, or some under drier conditions, some under hotter conditions, some under cooler conditions. So they have a wide variety of weather conditions that they can respond to. So they're locally attuned to the amount of water, the amount of the temperature. They also, prairie systems also cycle nutrients, they produce food, they stabilize soils, they build natural capital by building up soils and by being resilient to disturbances. And so we're looking at a way a prairie ecosystem builds a sustainable community through its diversity, through its resilience, and all in response to being locally attuned and responsive to the site conditions. And then we have some eyesight observations. One, this is Greg. He talked about geese flying periodically into his eyesight, and they land on an irrigation ditch that flows through his eyesight. And he's seen that the geese use a certain flight path into the trees and then a specific landing site on the water in the ditch. And he's concluding that they're locally attuned and responsive to site conditions by the way they approach landing, and must, for some particular reason, they have chosen a particular flight pattern. And John had submitted an eyesight example from honeybees, noting that there were, his summer garden was blooming with corn and squash and oregano and remnants of poppies, and the garden was completely abuzz with bees. And in fact, at one point, it was the sound of the bees was the most dominant sound. And he thought it was a nice illustration of the diversity of species being locally attuned and responsive to the cyclical processes of nature. So the summer gardening, the pollinating, so there's a cooperative relationship there between the bees pollinating the plants, which produce seeds, which then are food source for the bees in the, or for other animals in the next season or the next year. And then another example is a plant called hen and chicks, Semper vivum species. It's pretty common in rock gardens, probably have all seen it. It's kind of a rosette succulent plant, grows in cracks, nooks and crannies, requires very little soil, very little moisture. And it's an example of being locally attuned and adapted to conditions which have warm temperatures, very little soil, very little moisture, and it can thrive in these tight locations and kind of just expands as it can. And in my eyesight, I have some hen and chicks, and I watered one. I was kind of curious. I watered one of them quite a bit more than any of the others, and I've never seen this before, but it responded by shooting out this really long kind of flowering shoot. And maybe others have seen that before, but I've never seen a hen and chick that was maybe in response to quite an abundance of water can really can grow quite expansively. And so the other example on this slide that we weren't really going to talk about, but I'll mention just briefly, was it's a school, Upper Wright-Carton Community and School Library, that was based on the school itself is very flexible. The movable partitions that can respond to changing wind and sun conditions, and it was inspired by the termite nest construction, which I think most of us have heard about, where the way that termites construct their mounds, it can maintain a constant internal nest temperature that allows the termites to survive under what would be really inhospitable conditions in Africa. So I think that's it. If anyone from Team Communicate wants to chime in, I think that's all I have.
Well, great. I really enjoyed hearing your examples from your eyesight as well, because you're thinking about life's principles when you're out there. And just when you were talking about the flexible adaptive apartment buildings, it reminded me of a story I heard about McDonald's and their mission, and we could translate that into their function, is to deliver food quickly to where people are at. And when they really looked at how they were, the strategies they were using to perform their function, they realized that they were, when populations moved from one part of a city to another, they were actually just tearing down old McDonald's and building new McDonald's in other locations. And so they started a design project where they make McDonald's fast food restaurants that can be taken apart and reconstructed at another location, so they could perform their function by being locally attuned and responsive to where the people now want fast food. Interesting, but it saved them a lot of money and a lot of resources. So everyone did just a really great job. Life's principles are really important to understand, and we'll have some more exercises when we're down at the Great Sand Dunes in identifying and becoming more familiar with life's principles. But you all seem to be getting it really well. So let's move on to evaluation. So in integrating biology to design methodology, the final step is to evaluate the solutions that you've come up with. And evaluating is essentially ensuring that you've designed with nature in mind. And it's a quality control check to ensure that your design passes a sustainability test, as well as an audit to check for missed limits and opportunities. Ideally, the measurement tools were specified in the scoping phase as life's principles, so they have the legitimacy and influence to return a project to the creating phase for improvements. And in my discussion about recycling with Eric Lombardi, who manages EcoCycle here in Boulder, he made a really specific point about the need to really specify how you're going to be dealing with your recycling efforts in your town. And he got the county commissioners in Boulder County to agree to a zero waste goal by, I think, 2050. And he said because they already agreed to such a lofty goal, he has the legitimacy and the influence to request the next step and to say, well, now if you don't build a composting facility now I guess he put it in place maybe in 2008, 2009, you will not meet your goal that you set for 2050. So getting managers and people in high influence on your project design to make a commitment to use life's principles as a measuring tool in the very beginning is really an important step, because then you have the legitimacy and influence to go through your project and return it to the creating phase if life's principles are ignored in the design. So if the objective of the evaluation is more than just an inspection to determine compliance with minimum quality and safety standards, any evaluation can enrich a project if there is an opportunity to revisit the design and incorporate improvements. Similarly, audits are most effective if they occur before the final design is implemented, and it allows for a chance to return to the design table and make improvements that sometimes are impossible to do once the project has been built or completed. So evaluating using biomimicry is an innovative way for humans to critique their project's appropriateness or rightness. Evaluations with nature as measure provides a higher standard than conventional measurement tools, since they are based on natural models, which are functioning within their specific context as well as exemplifying life's principles. It would differ from current evaluation systems because life's standards incorporate more than just the project's performance, safety, and meeting quality goals. A biomimetic evaluation includes all those aspects, plus it recognizes the context that the project is going to occur in. As we discussed in the scoping lecture, context with regard to sustainability means Earth's context. A truly sustainable design should recognize these operating conditions, characteristics of water, sunlight, and gravity, dynamic non-equilibrium, limits and boundaries, and cyclical processes. So how do you evaluate using nature? The set of life's principles is the primary metric for judging the fit or rightness of the design, asking a series of questions that look for the ecological feasibility of the proposed solution. And when I sent out the metric for the worksheet for using integrated biology into design methodology, I included a life's principle checklist in the evaluation column for that. So you'd want to ask the questions like, does the design fit in within the Earth's operating conditions? Does it draw on deep patterns and principles of the natural world? Will the design function like the other 30 million species that are alive today? So the process of evaluation should follow the process you and your team are accustomed to, but need to consider the inclusion of some additional parameters or questions. So if you've gotten your management or your upper, whoever's the decision maker in your place of employment or in your own life, if you've made a decision to incorporate life's principles up front, you would have the legitimacy and influence to ask those same people to include the additional parameters and use life's principles as the evaluation tool. So the Biomimicry group has compiled these as a checklist, and it was included in your lecture notes a few lectures back. And the checklist is designed not as a yes-no kind of tool, but rather encourages you to ask each of the items, how well, if all, does our design do, and go through each of life's principles. So we've said that this list of life's principles is the primary metrics for judging the fitness or rightness of the design. And the process of evaluation needs to occur towards the end once you've come up with a solution. If your design does not match a guideline well or at all, this design needs to be addressed by reconsidering this guideline again in the creating phase. However, as you go through the evaluation process and find your design is not holding up against life's principles very well across the board, you may need to revisit the scoping phase. Perhaps your function and context were not clearly or properly defined. Or perhaps you did not accurately distill the deep design principles from the creating phase. And this is one reason why we're having Taryn Mead join us at the in-person session, so she can really help with this step, because abstracting and pulling out the deep design principles is just a really difficult task, and you want to be sure you have them right. So by scrutinizing your design in this way, you're essentially pre-testing it for success in the big picture and in the long run. Organisms that are alive today didn't really have a chance to do that. They pre-tested it in a life and death situation, and the 99.9% of organisms that are extinct are the ones that failed that test. You may discover that your emulation of nature was actually very shallow. The case study for the Great Sand Dunes that I passed out for their hydration challenge is an example of a shallow emulation, as the team who did this project during one on-site workshop without the benefit of researching the biological strategies. So we were just at the Great Sand Dunes and did this whole 6-month webinar in 3 days. So the result was a very shallow emulation, but still a good idea. The solution here at the Great Sand Dunes was a good start to designing a better system, but the solution does not meet all of life's principles, and I think you could see that if you went back and read the case study. It's tempting and rather easy to crudely mimic the shape or pattern in nature, ignoring function and context, but be wary of this tendency. Abstracting and emulating an abstracted design principle moves the design process away from a slavish copying of nature, which is a frequent point of criticism for some biomimicry objectors. An alternative approach to the checklist is to build a matrix of life's principles against each of the functions of your design. And life's design for water is one example of a matrix for water, and it outlines the different functions against the life's principles and looks at the strategies nature uses. But by systematically filling out the entire matrix for how each aspect of the design follows each of life's principles, you can easily identify areas of weakness and strength and address it. This type of evaluation takes a significant amount of time, but does ensure that your evaluation is objective and thorough. If the success is high stakes, it's worth taking the time to undergo this process. So the project I did with my 2-year certificate program design team, we developed a matrix for the Cuyahoga River Valley project, and it's rather large, and I'll bring that to share with you during the in-person session to see how filling out such a matrix really shows you where the holes in your project are and helps you identify where areas of strength reside. So when life principles are used as a measurement tool, each individual principle is assessed for each aspect of the project, recognizing that many of the values would depend on the specifics of the project and project location. In this way, the evaluation can pre-test for real-life successes that function well in the context of your world. Life's principles, when used in a matrix of interconnected systems and principles, as noted earlier, is extremely useful in identifying missed limits and opportunities. Should you find missing or weak expressed elements, you have identified where there is a potential to better leverage a limit as an opportunity. So lastly and significantly, the evaluation phase encourages us to also ask, what wouldn't nature do? The answer to this question can provide incredible foresight in anticipating where limits be exceeded or strategies are likely to fail under one parameter or another. So at EPA, we usually get a final design ideas to evaluate. Using life's principles as the evaluation approach provides the designer with a heads up on where their designs may fail in the future. So for example, if you have a project and you compare it against life's principles, but you have no control or you have a limited budget where you are unable to design those factor those life's principles into your design, you do get a heads up to say, you know, in the future, here's a real hole in our project. We don't have any redundancy, for example. And so if this system fails, we need some kind of a backup. So while we can't build the redundancy into the project right now, we should note it and get community leaders or whoever is actively working on the design to recognize that you need additional phases in order for the project to survive long term. So just imagine for a moment what our world would look like today if many of our current unsustainable designs were forced to undergo the question of what nature wouldn't do prior to being set upon the world. Now imagine if every design from here forward was able to confidently perform and reach each of nature's guidelines. A world empowered by life's principled design genius sounds pretty good to me. So we'll work more on this when you get your final design solutions, and I'll be available via email and phone in the month of October to help teams individually look at their evaluation if you need that additional assistance. So let's move on to a different topic, communicating using biomimicry. And I sent a link to a pre-recorded PowerPoint on how to speak about biomimicry to engineers that I put together for the biomimicry group. It's important for each discipline that learns about biomimicry to think about and identify the best leverage points to introduce this emerging science and to recognize innovative leaders in their field that would be willing to try new ideas and approaches. Recently, I've been reading the book The Blue Economy by Gunther Pauly, and in the beginning chapters of his book, he identifies how and why products make it or don't make it to the market. And we all know there's a lot of barriers to bringing innovative products to the market, even if it's a really good design with really better, like low energy processes, for example. Although the approach that Gunther Pauly identifies to using nature is, in my opinion, more like nature as model, measure, and money, because it's really based on making our designs more successful in the current marketplace rather than learning how to use nature as our mentor. He does go into detail about a lot of nature-based business ideas that are really astounding, so I've been enjoying reading that book and recommend it to you. I also provided 2 links to the 2 Forest Service Western Collective Accomplishments reports in your homework, and just advise you to check them out if you have a time. When biomimicry was presented to the Deputy Regional Foresters of the Western Collective in 2008, they decided to start engaging this science by introducing the language of nature in their reports and guidance documents. They felt it would be a way to reconnect foresters to the natural resource they protect and manage. So starting 3 years ago, I added documents to include language of life's principles, and it has led to increased interest in biomimicry by Forest Service managers and staff. So read through a few pages of the report and see if you can identify life's principles being used to explain ideas, approaches, and project results. Then read through one of your own reports, perhaps even the final case study your team is drafting, and identify where edits to include nature-based language make sense. If you have any questions about translating your ideas, just ask a biologist. If that is a good translation, that would be one place to start. So I perform this function for many of the Forest Service Western Collective documents, and I'm able to help edit documents from your agency or your business and help you learn how to do this. It's another way to develop a better understanding of life's principles and their meaning. As a result of the work in the Forest Service, right now they're very interested in the results of the organizational team, Team Organize, to help them develop an organizational structure for their Sustainable Operations Program that will adapt and evolve over time. So let's talk about the in-person session. So we have several people from each team will attend, and remember your job is to relate some of that information back to your team when you return. The significant information that you'll receive from Taryn Mead on your abstracted results, it will be the most significant information you'll receive, and I'll be present at both of those sessions, at every team session, and help take notes about what she says so that the teams can listen carefully to what she's saying. So you're required to bring printed copies of all your biological research so that Taryn can reference it if necessary. And I've sent copies of the summary reports to the instructors, and I'm preparing a packet for park staff who will participate in the workshop so they can be up to speed on what each team is doing. So I need all the people who are attending to arrive at the entrance to the Visitor Center at 1 o'clock on Tuesday, September 11th. If you arrive early, you can proceed to Campsite A at the group campsite area, and I'll be there till about 12:30. You will have time after the presentation and before it gets dark to set up your camp, so don't worry. Remember to bring the items listed on your registration form along with a camp chair. There are these picnic tables there, but we want to be able to move our chairs around to hear about the different presentations. You will each be assigned some camp tasks which rotate around and give all persons some work time and some free time. So when you arrive at the Visitor Center at 1 o'clock on Tuesday, September 11th, we'll move to the Parks Conference Center for their personnel, and the public does not have access to this area, so we must go in it as a group. So at 1 o'clock, I'll take the group back to the conference center, and then I'll come out and see if there's any stragglers. The Great Sand Dunes biologist will present an overview of the park ecosystem, and this is where you will chime in and present the facts that you've been researching about the San Luis Valley. Jason Gearhart, an expert in water systems as they apply to permaculture sites, will provide an overview of water systems using nature's design. That's why we're going to meet at the conference center. He has a PowerPoint. I do not have cell phone coverage at the park. If you need to notify me of a problem or issue, you can call my work number and leave a message. I will check this twice a day and receive messages. So Nestle Torres and I did a site visit last month. There are no electrical outlets at the campsite. The park will provide an area where you can charge your cell phones and computers, probably hooking them up and leaving them overnight, for example. It's about 3 miles from the campsite in the resource manager's office and work area. There will be some guests who will be joining parts of our in-person session. So in addition to some of the people in the park, I know that there's 2 biologists who may attend, and the facility manager may also attend some of the sessions. Patricia Logan is a writer-producer with a background in TV news, cable programming, organizational videos, and documentary films. She's won 3 regional Emmy Awards for her work, and she specializes in telling stories about the natural world and our relationship to it, including the work she did as a reporter for CNN and TBS, and as a writer for several films for the National Park Service. So in 2002, because she was interested in these areas, she went back to graduate school to explore the complexities beneath the environmental issues she'd been covering, and earned a master's degree in American Studies from the University of New Mexico, where she focused on environment, science, and technology in American culture. We met at a workshop, and she became very interested in biomimicry, and she has interest in filming parts of our workshop, as she has an idea for a film about biomimicry, and she'll explain this process to you on Tuesday night over dinner, and also ask people if they have any objections to being filmed and take that into account. So our second visitor that I just found out about yesterday is Dr. Michael Gorman. He's a professor of engineering and society from the University of Virginia. He teaches courses in ethics, invention, and the psychology of science and communication. His current research is in the kind of interdisciplinary trading zones that will be needed for scientists, engineers, and other stakeholders to collaborate on the development of new technologies. And I met him in 2006 at a workshop, a sustainability workshop that was held out here in Colorado, and we became good friends. He likes to come out here, and he does teach a class about the social issues that arise where national parks butt up against community needs and how those are resolved. So he came out a few years ago and did some research on Rocky Mountain National Park, and just coincidentally he emailed me last week and said he was coming out the very week our biomimicry class was meeting to do the same work down at the Great Sand Dunes. So most likely he will be camping with us, doing his own research during the day, but I encourage you really to listen to some of his ideas. He's a very innovative person, and really the need to develop language so that we can trade ideas and thoughts between the different disciplines is definitely a part of biomimicry. And so it would be a real pleasure to have some of his comments. The park may also invite staff members to hear about your final presentations on Friday. So for that final presentations, I'll be bringing flip charts and a whole bunch of things that you can use to develop flip chart presentations with, just to give a 30-minute overview of what you've gotten so far, and develop those flip chart presentations for the last day. And the teams will also, if you look at the agenda, you'll also have plenty of time to put your ideas together. I'll send out tomorrow a list of the participants. Nestle put together a good Excel spreadsheet with that so that you can self-organize into carpools, which I understand some of you are already doing. So, are there any questions or comments on the in-person session? So I'll open that up if you would ask if anyone raises their hand.
Marie, what would you expect the weather to be like this time of year?
You know, when we went down in 2009, I was very cold at night, and we went down the same week. The San Luis Valley is typically 10 degrees cooler than the Front Range of Colorado. So the nearest town is Alamosa, Colorado. So when you're packing for your trip the weekend before, I would get on a weather, site on the internet and see what the weather is planning to be. I keep looking at the weather for Alamosa since I spend so much time down there, and all summer long it's been about 10 degrees cooler, where the Denver metro area was in the 90s, it was in the 80s, and then again getting much cooler at night. It even had frost on the ground one of the nights we were down there in 2009. So, and I did not bring a sleeping bag that was heavy enough. So just pay attention to that. I don't really, if I could predict the weather, I could retire from EPA. And so that's what I would recommend. Other questions or
I'm going to call on Deirdre.
Okay.
Go ahead, Deirdre. Can you, Deirdre, are you there? Okay, she did have a question, and I unmuted you, so you should be able to talk, but we don't hear you. Okay, well maybe I'll leave you unmuted for a minute in case you were able to get on, but you can also type in the question and I can read it to Marie.
And I have one more slide to go through, and if anyone has a question about the in-person session, type it in and we'll address those before we end the webinar, or of course you can always contact me, and if you have questions I'll be around from now until the workshop. Okay, we'll talk. Did you have something, Mila?
Yeah, hold on.
Okay.
Okay. For those of us who can't make it, will the final presentations be available for us to see afterwards?
All right. Well, that's just what I'm going to talk about.
Oh, perfect.
So the final presentations at the Great Sand Dunes will just be where the team is at that point. So it may not be the final. It's like, well, wow, we really learned this. We really had an insight, or we're closing in on our final ideas. So it'll be a chance to wrap up and summarize what you've learned in the workshop, and each team has already summarized their work to date, so it won't be a huge amount of work at the site that will be done. Okay, the final case study reports, the part of the project that usually goes undone, but I'm a big taskmaster for this. So the final case study reports are due to me by November 1st. Nestle and I are writing the sections on the biomimicry methodology, so this does not have to be part of your report. What I envision is to put together a paper that talks about the whole effort of the workshop, the breadth of the disciplines and the career paths for the participants, and talk about the solutions that came up with each of the 4 challenges, and at the in-person session and at this final webinar, we can talk about how we want to market that, if we want it published, or if we just want to use it in each individually to talk about the work that we've done. So we do want 4 individual reports. Do we want, is the question, do we want 4 individual reports like the case studies for the TRI data and the Great Sand Dunes workshop, or do we want 1 report with the 4 solutions identified? So that's still a question. So I did submit an abstract about this workshop to the Colorado Bioneers Conference that's held in November, the second weekend in November at the University of Colorado. And those of you who are not familiar with Bioneers, you should get on their webpage and check it out. So the CU Bioneers is held later than the National Bioneers, and it's November 9th through the 11th. So if this presentation is accepted, I've asked for a panel discussion where I would introduce biomimicry in a very short overview. Many people, I've spoken there 2 years prior, so many people are already familiar with biomimicry. And then present information about using the biomimicry, integrating biology into design methodology, and then ask 1 person from each team to be on the panel and present a story about how your team did a part. And the parts that I've identified is identifying a real challenge, so how you identified your function, developing a design brief for the function. That's, the context, the operating parameters, and integrating life's principles into the design brief. How you discovered, that was all the work that you did with Nestle and with your team to find the best natural models and abstract the strategies. And then the emulate and evaluate stages. So I thought by going over the integrating biology to design methodology and then asking each team member to talk about it in a story form really engages the audience. It just doesn't go through a series of dull PowerPoints that you've all seen in these webinars. Then in a second round, we'd have each team representative provide information on the solutions they arrived at. So several people have volunteered to present for their team. So far I have Doug for the Communicate team. Lynn and Laura have offered to present for the adapters. Sarah Dawn has also agreed to volunteer to adapt. So think about who on your team will present if our proposal gets accepted, and how your team will tell their story. So that's all I have this last webinar. Is there any additional questions or comments?
I think that's it for now. Oh, Marie, did you want to say, were we going to reschedule another?
Oh, I'm so glad you said that. Yes, I have a note here, and I completely ignored it. So just before the webinar started, Mila and I set a date and time for the final webinar where each team will present their solutions. That'll be on Thursday, November 1st from 10 until noon, the same time slot. So it's the first November, it's the first Thursday of November. So we'll have our final case studies due that day, along with Mila will host the final webinar. So each team will have up to half an hour. You don't need to take the whole time to go through a series of PowerPoints to present your final solution to the rest of the group. And just because you have 30 minutes, don't feel like you need to use 30 minutes as long as you tell your story and leave some time for comments and suggestions. That would be great. So just a heads up on that, and we'll send out a notice on that as well. Thanks, Mila.
Yep, sure. Okay, I think that's it.
All righty. Well, I am so excited about the in-person session, and there's several people who asked me if they could sign up later, and that's fine. I needed to have a real general understanding of who will be coming so that we could plan and we could carpool. I will be purchasing the items for the workshop on the 6th and 7th of September, so if you need to cancel or if you want to add your name to the list, that would be the absolute end deadline. If you have signed up and then you need to cancel after that date, remember that I've already purchased the food that you have committed to eat. And so you will be responsible for the cost of the food and the campsite that we've reserved, the $185 plus $25 registration fee. What I will do is with those finances, I know many of you are putting in your own money to attend. I'll keep a detailed accounting of what the money is spent on. What we did in the last workshop is at the end of the workshop, anyone who wanted to take a share of food that was left over were welcome to take that. And then the remaining food was donated to the park. And we'll do that again this year. And if there's any funds that are left over, I will just distribute those to the paying people at the end of the webinar as well, so that in case we don't need all that money to feed everyone, we'll just return it to you. So, okay.
Maria, we kind of lost you on that last money part.
Okay, well, let me just restate it. So I'll keep a financial accounting of the money that's spent to secure the food and the ice and all the other miscellaneous things that we need for the workshop. And if there is funds that are left over at the end of the workshop, I'll just bring those to the site and I'll just distribute them to the participants that paid at that time.
All right, sounds good. Any other questions? I think that's it.
Okay, thanks everybody, and I'll see you next month. And let me know if you have any questions or comments. I'd be glad to help you out with the progress of your final case study. Almost finished. Okay, thanks a lot.
Thanks,
Bye.
Marie. Bye-bye.
Bye.
Bye, everybody.